Cool. So I'm just gonna go to the folder we were working on last. Cool. So here we were on. Good morning. So, or anyone maybe during the week, or during our weekend, have any question about what we saw before, creating tables, inserting data, outdating that data? Yes.
You had done it a different way to, so for example, the user 2 declines or decides rather to delete their account from social. But did we get that far? I forget where we left off. But basically that same thing, where to do those types of things, I took it to basically you had to clear out all of the other connections before you could get the primary connection, as it were, of deleting the user. You had to first get rid of the likes and get rid of the posts, then get rid of their
That's correct.
user.
Yeah.
Had you shown us a different? I feel like you should show us a different way to do that.
Yes. So it was the undelete cascade.
Right.
But let me. So this is what the undelete cascade means. So I'm going to give you some time to read this description.
So as long as you put undelete cascade on any children of something like a primary like user, like that's where you're putting the undelete. You don't have to put undelete on the children.
Let me see. I'm not remembering exactly if it was on the children or the parent. It's on, yeah, so it will be on the. This seems to be, yes, on the children child table. So here when we have two tables here, like products and inventory. What this will do is when you remove a product that is referenced in the inventory table, because and by that will be this line here, reference, the inventory is referencing the products table, product ID column. So when you remove a product, what this will do is it will also remove, if there is any rows in the inventory table referencing that product, those rows will be eliminated. Cool. So just last time we left, so we had left here, delete from post, the user 2 deletes their account. We have delete from users where ID equal 1. And here, so this is going to take care of when we remove this user, because we have undelete cascade in here in the post. We have undelete cascade on the post. So all the posts will be removed from that user. And because we have, and the likes that that user also gave will be removed. So when we remove a user, because these two are referencing the users table ID column, and we have the undelete cascade constraint, whenever we remove that user, the post will be removed, and the likes of that user are going to be removed. If you did that manually, that's fine. You should try to refactor your database code to move to undelete cascade. So let's maybe take a look at this. So let's do, let me comment some code that we don't need. So let's see this working. So user 2 decides to delete their account. Cool. So actually, let's do it with user 1. So user 1, in my database, user 1 has 3 posts. And I don't remember how many likes, but we can check quickly here. PSQL, connect to Facebook DB. And then once here, let's do select star from post, where poster ID is equal to 1. So we can see that poster ID or poster 1 or user 1 has these 3 posts that belong to them. And let's see how many likes this user has given. So select star from likes, where liker ID, oh, so this person hasn't liked anything. User 1 hasn't liked anything, or maybe we removed it out around here. I think we removed some of here. Yeah, we removed some likes here. Let me comment this out to at least have that user like something, own some post, and then let's remove that user and see how the likes are not going to be there, the posts are not going to be there anymore. So let me run this file, psql-f. Cool. We go inside PSQL again, connect to Facebook, and then let's do select star from post. Oh, wait, no, it doesn't have any posts anymore. Do we have other deletes that I forgot to comment out? Oh, I executed this. So, well, this line executed because I didn't have it commented. This is removing that user. We saw that that user had 3 posts. Now when I try to get those the post, when I try to get the post, where the poster ID is equal to 1, I get an empty table, or I get an empty result. That's because when we remove this user with ID 1, and the post ID had the post table had a poster ID referencing this user, those rows were also removed. Similar if I do the likes. Now I'm trying to get the likes for this user, and those are gone because we removed the user and everything that was referencing to it. It's like, imagine, actually I don't know if this is true in a social network, but imagine you give likes, or you're very active and you post a bunch of stuff, you give likes, and then you want to remove your account because maybe it got hacked, right? You go to the settings, delete your account, you don't want any of your posts to still be there, and you don't want any of your likes to still be there. So the undelete cascade will allow us to remove other stuff that is referencing that user. Does that make sense? Cool.
Pretty much all tricks of your existence on the social.
Yes. As long as they're connected with referencing the user's table. Yes. If they're not connected, if we don't have like references, if the poster ID is not explicitly referencing the user on the ID, then we're gonna have like orphan posts, right? Because they don't belong to anything, to anyone. So that's the importance of explicitly creating this relationship, these references. Cool. So we did that, and then these are the most interesting questions. So find the user that has given the most likes. Douglas, how did you approach this?
So what I did was I made a nested select, a select inside the select.
Okay. So tell me what the inner select does.
Okay, so the inner select is first, it's selecting the liker's ID from likes, grouping by the liker ID, ordering by the count of the liker ID, descending, and limiting to 1.
Cool. So where the liker ID, no wait.
Oh, I'm sorry. So from the beginning, so
Select
liker ID from likes, grouped by liker ID.
Or actually, before we move on, let's look at this. So I'm gonna select. Let's look at the table. So we want to find who is the user that has given the most likes. Who is the most active in this social media? So let's look at the likes table. Select, sort of as a human, first see who is the user that has given the most likes, and then let's build the query from there. So select star from likes. Cool. So we have this table. So here, as a human, we could just look at the liker ID column and see which one of the IDs is the one that is most repeated, right? So here we see that 2 appear only once, 3 only once, 4 appears 4 times, or 3 times, and then 5 2 times. So who's the user that has given the most likes? 4, right? He has given 3 likes. This 3. And you see how we were sort of counting. We're going to do the same thing with SQL. So go ahead, Douglas. So you were saying select liker ID from likes.
Yeah. So from likes, you want to group by liker ID, then order by count parentheses liker ID.
I see.
Descending.
So let's look at this group by liker ID. So first, I guess let's look at this first. So this select liker ID from likes, this is just going to give us this column, the liker ID column. Then what we're going to do is we're going to group by the liker ID. So, oh, and we'll need something else here, Douglas, right? In the select, you have a count here.
I didn't grab it. I was only remind. I didn't think I needed 2 rows because eventually I don't necessarily even need any of that. It's just going to grab from the Likert ID itself in the outers to be able to reference that one number to tell me which user it is, so I can bring up all of their information.
Got it. So let's look at this. Would this query work as it is? Select Likert ID from likes group by. It's not gonna work. Why do you think it's not gonna work, Alexandra?
Because like it's not gonna like order it, so like if it has the most likes, it's just gonna group it.
Yeah. So it's actually, I think it's not gonna group because when we went to group, we want to specify how do we want to group, sort of. So let's look at what this is gonna give us. First let's look at this. This is just gonna print. Select Likert from likes. So let's look what that looks like. This seems. Wait, this seems like a longer table than the one I had. Oh. Let's see. Oh, I guess I inserted some other likes. Here we have. Where did these likes come from? Yeah, I guess so. We have these likes. I don't know why we had less. Oh, we had less because I removed user 1 post and user 1 likes. Oh, so that's a good point. So do you remember that the previous point we were seeing was how to deleting a user, right? And we saw that when we delete a user and it has any posts that belong to that user, those posts get removed and those likes get removed. That user had 3 posts. So 3 posts and there were a lot of likes. Once we removed the post, everything that was liking that post also was removed. And then we ended up with a smaller table. Does that make sense? When we removed user 1, there were some posts that were created and there were some likes that other users liked user's 1 post. Now, when I removed user 1, all the posts that belonged to that user were removed, and all the likes associated with those posts were removed as well. So let's look at it. Look at this here. Let me connect to that database. Oh, by the way, this is another way in which you can jump directly to the database, like PSQL-D for database, Facebook DB. So you don't have to do PSQL and then inside \c. These are sort of connecting directly. Cool. So we see that these are the likes. A ton of likes because there are some posts, and then we can see the posts of user 1 are still there. And let's see the likes from user 1. These are the likes from user 1. So I'm going to remove, delete from user, where, just so that we have a more manageable table, where d is equal to 1. What this is going to do is going to remove user 1, it's going to remove all the posts that belong to user 1, it's going to remove all the likes that user 1 gave, and it's also going to remove all the likes that were given to user's 1 post. Now remove, if we select the likes again, now we have the smaller table that we had earlier. So let's work with this smaller table. So here we found that user with ID 4 is the one that has the most likes. So let me sort of to get back there. Let me comment this. Yes.
You pretty much deleted likes from user 1 because you did delete from users where
Yes. That's fine. So let me quit from here. Let me run my SQL file. And we have this. So this is the select. We're back on track here. Where? Here. Select liker ID from likes. So then what we want to do is we want to, by looking at this column, it will be great if we could group this by the IDs that are the same, right? And then count. Basically count the number of 4, count the number of 5s, the 3 and 1. Right? So if we group by here, we would expect to group, but we're gonna have this syntax error at or near group. Oh, sorry, this is because I have an extra there. This is not the actual error. Cool. So here we group by liker ID, right? But then we ended up sort of losing the count and getting like uniques, basically. Douglas, what else do you have here?
I follow that by order by count, and then in parentheses, liker ID, descending.
I see. So right here,
Exactly.
and that's it for the inner query, right?
No, there's still one. Then I limit one.
Then you limit one. Okay, but let's look at this. So here we ended up sort of grouping by liker ID, and we ended up with unique liker IDs. It would be great if in that grouping we could count. We could count how many do we have of every user. So what we could do here, let's do this. In the select, I'm gonna have this is known as an aggregate function. Count. Aggregate functions are very commonly used with group by. And you should read about it on the Postgres documentation for aggregate functions. There are ones that are very useful. So what I want to do is count the number of liker IDs. I need a comma here. And then here I'm going to say, let's just do it like that. Cool. So I'm just using this aggregate function here on the same column that I'm grouping by. What this is going to end up doing is counting how many times we sort of group, or how many elements end up in the group that we're forming. We're grouping by liker ID, so we want to sort of associate all the same group, all the same liker ID, and consequently, what we want to do is count. So let's look at this. So we have that we grouped by liker ID 3, and we only found 1. We grouped by liker ID 5, and we only found 2. Right? Let's look at the table right before it. Select start from. I think this is important. So let's look at the table right before. So this is the likes table. We're grouping by liker ID, right? And we're counting how many elements we end up in those we end up with in those groups. So here we found that there is 1, 3, because if we find here in the table, there is only one post that user with ID 3 likes. So we can tell by this table, by the result of this query, that we have that user liker ID 3 has liked 1 post. Now we group. Now this is going executing, and the next group that it did was grouping by 5. We find that the count of that group, the count of elements that end up in that group are 2. What 2? These 2. Yes.
Can you also count by like how many IDs show up or how many post IDs show up? Or does that have to be how many like IDs?
In this case, it can be any of those, yes. So here we find that user 5 likes 2 posts, and this is we end up with this count. User 4, we end up that when SQL was grouping elements by the liker ID, found 4 rows, and that's the count that we have. So not 4, 3, and that's the count that we end up here with. When we group by liker ID 2, SQL found 1 row. So with this table now, we are able to have the number of likes that every user has. So what Douglas did next, or any questions up until this point? We're sort of counting how many likes all the users have given. And we end up, this is what this table is about. Counting the number of likes that every user has given. So, questions, comments? Yes, Peter?
Can you re-explain how group by works?
Yeah, so group by what we'll do is what the name indicates is going to try to group rows by whatever column you specify. That's what it's going to do. It's going to group rows by whatever column you're specifying. So here, what I want to do is, so here I run that, and if I group by liker ID, I end up with sort of unique likers, because I group by, SQL group by, but I didn't specify what do I want to do with those groups, right? So what I want to do is I want to count how many rows ended up in those groups, and that's what count is going to do. And order by are commonly used with what are known as aggregate functions. Like count is one aggregate function. You probably saw count on SQL too, right? There are other aggregate functions.
So the
Yes.
order that it's in right now, the liker ID order is like 3542, is not specific.
Say that again?
The order that the liker
Uh-huh.
IDs are in is not like specific. Group by doesn't sort them in any way.
That's correct. Group by doesn't sort them. It just groups.
It's just however
Mhm.
it gets them, you just put them there.
That's correct. And I'm curious why this order. I think this order really doesn't matter. I'm curious why 3 ended up first, 5 second, and so on. But that is, yeah, that's some internals of Postgres that I ignore. Yeah, sure.
So, why don't we pass liker ID and count it? We're just counting on the liker ID, like that's how we count it.
Yeah, so let's look at the documentation for count. Aggregate functions, Postgres. So there is, I like this website. This website is good. Postgres tutorial. It's a little bit more plain English than the official documentation. If you find the official documentation very dry, let's look at this is sort of like MDN versus W3 schools, where the official documentation will be MDN, very technical. Let's look at the technical documentation first, and then let's go back to this one. So aggregate functions. So there is this table that has them all, and here we find count here. And the description is just number of input rows. So going back to the group by and the count, group by groups and count counts the number of rows in those groups. That's it. So here, I wonder if he has anything else. Let's see. Yeah, that's pretty much it. Or maybe this is a link. No, this is not a link. So I'm not sure, to be honest. But let's look at it here. The Postgres aggregate function, count. Return the number of values. Doesn't say anything else. This is an example. To get the number of films, you use count start function as follows. So this is just counting the number of rows. That is what count does, counting the number of rows. Here it will count basically how many films do you have, how many rows do you have in the film table. Let's see if there's any other explanation for count. Postgres count function is an aggregate function that allows you to get the number of rows that match a specific condition of a query. Yeah, you should take a look at this if the count function is still a little bit confusing. So up until here, other questions. Select liker ID from likes and then group by liker ID. We want to count how many liker IDs end up in these groups. So again, here we have that by this query, select liker ID, count liker ID from likes, group by the liker ID, we end up with 4 groups. 4 groups where the first group for liker ID 1 has a count of 1. That is saying user ID 3 only liked 1 post. User ID 5 liked 2 posts. We can see them here. These are the 2 posts that the user ID 5 liked. User ID 4 liked 3 posts. These are the 3 likes that that user made. And then liker ID 2 likes 1 post. That is this one.
So like count is counting like how many times the number shows up.
So, yes. In other words, yes. Cool. So once we have this, what Douglas did was order by, and what he's going to be ordering by is the count, right? He wants the highest count first. So let's do descending. Order by to count liker ID descending. So here we're selecting it just to sort of for us to see it. We don't really need to select it. But if we do this, then we end up with a sorted table. Now we have a sorted table where it's being sorted by the count in increasing order, or descending order actually. Where we have the biggest count at the top and all the smaller counts. Questions about the order by? We just literally sorting the table. This is sort of like, you could think of order by as that sort of Postgres. So once we have this, we know that the question, remember that the question is find the user who has given the most likes. Here we already, first we verify sort of us as humans that 4 was the liker ID that had given the most likes. Then we started to build this query. And now we order that result by the number of count. Now we know that the liker ID 4 is the user that has given the most likes. And Douglas was only interested in the top. Basically, who is the liker who has given the most likes. So he just limits the result by 1. Limit 1, what we'll do is return only the top row. Limit the result by the top row, and then this is we're only gonna get that one. We end up with the top row that we had before. So order by limit. Questions about order by and limit? Yes, John? Yeah, so let's remove that and let's see the result. So this is the result of this query, this last table here. So how many rows do we end up with? 4. And note that we order by the count because we want the biggest count at the top. Now what limit is going to do is it's going to limit the result here to only be 1 row. So if we do limit 1, we end up not displaying these rows or not returning these rows, only the top row will be returned. And when we run it, we see that only the top row was returned.
So if we hadn't ordered it before, it would probably give us whatever we had.
Great question. So let's comment out the order by. And we end up with a different liker ID, whatever was at the top when we group by liker ID. Yes?
Is limit by, or limit how the, I forget which one of the APIs we're using only gives like 10 results. Is that kind of behind the scenes how they're only giving us 10?
That's correct. When most big databases or big APIs like GitHub's or the biggest ones will use something that is known as pagination, where you only get a limited result, like 10 results, and then they give you some instructions to get the next 10 results, and so on. And that sort of thing where they give you one set and then how to get to the next is known as pagination, like literally from turning pages in a book. Cool, so yes, this is a very important point. Yes?
So, limit for use.
Yes, limit only affects rows, and in the sense that you're gonna get as many rows as you ask. If I do limit by 2, I'm gonna get the first 2 rows. Yes.
So we block out
No
the
worries.
2 again. But if you, what I found was really interesting, I noticed before, if you put the order back, the order by descending, and turn off the limits, you see all of them. When it hits, as it's going down, there are 2 1s by count. And rather than just sort of shrugging its shoulders and throwing it out, it further orders it in descending liker ID number. It brings back 3 2.
I see. I'm not sure if that will be reliable. We should try on a bigger table.
Yeah.
I don't think that will be reliable, but we'll need to try on a bigger table, yeah. So we group by, we count, we order by the count in descending order so that the biggest count is at the top, and then we'll limit the result to only be the top row, and we end up with the ID. We end up with the ID of the user that has given the most likes. Once we have this ID of the user that has given the most likes, if we want to get all the information from this user, we just need to use this number 4 in our select star from users where ID equal 4. Right? But before we do that, other questions, comments about this? Some people format this in this way. Additional questions up until this point? Yes.
You can put as the name of what you want the council to be.
Mm-hmm. Yeah, so you can rename this sort of as a side note. Here you see that this column ended up with the name count. That is the same name as the aggregate function. You can change that if you want by saying as, say as like num likes. What this is going to do is it's going to sort of change the name of this column to be num likes. So note that this changes the name of the column on the result table or on the return rows. It doesn't really change the name of the column on your table. Yes.
Can you take the limit one line out and run it down?
Take that one out.
Yeah, but let's see.
Or this will be more like num of likes or post likes. Num of likes. Yes.
Before you say that as num of likes doesn't really change the column name, it's like it doesn't change the column name.
I said it changed the color name on the result, but not actually in the table. Like your table is still going to be, this is not affecting your table. This is only the result. Yeah. Cool. Check with your neighbors that we have all this SQL query. This SQL query.
So like, why is kind of like why the count is the same? It's like count or
That is because every row represents is just a like. So it doesn't really matter what column I'm counting. It's because the rows themselves represent a like.
Because what we're trying to look at, the question is trying to answer is find out the user from all of this information who is making most of this. So the first question you need to figure out is that flashes. So that's what this is. So typically, I mean, technically we don't have anything else. That's just an visualize it. Selecting the line of the library. So I'm not going to touch that back. And if you need that, there's no one. And that's what the first one. We're going to go to columns. It's like, from that, we're telling them the tables group by what they actually do is grab every unique instance in the library. Exactly. So if you didn't have counts or order by grouping by library, what you're going to get is like a list, like a column of unique instances of library. So if you're looking for like, hey, I just need to know how say how to like a table where you're entering a bunch of like the same like you just need to know how many like names, like how many students all together put there. So you can truncate that way. And you can just group by students. And you'll just get a list of how whoever's put it if that makes sense. However, we want to get that group into this number. So if you order by counts, well, that's students. But count like that, you can see right next to each instance how many they show up as lists. The order by count allow them, especially by the set. You could buy a set here as well. It would be one on top and three on bottom. But if you order it, that's just sorting by like the breakouts. And then the very last one, talking about there, because in that step, we're only getting that's the information we need. Exactly. So if you wanted like all this 4 lines, so you could do limit 4. That's kind of necessary. You could do limit 3, and you get only 3 years. And that's also how visibility is over. It's really impossible to do this. Yeah, one of them didn't give us like all of them at once. But and that's how we say that that's how that's done. It's called gamification. They're going to give you a small chunk, and you can actually come up with from that. However, that's sort of separate. So everyone's supposed to which is then like, well, now we have that knowledge of what it means. How do we get all of the users information to display
Okay, so questions that resulted of the conversation with your neighbors about this query. Yes. We're gonna use the exact same thing, yeah. Or sort of the exact same approach. Yeah. So they sort of like the same way that we do it in JavaScript where we break down a problem. Here we're doing the same thing. We're just first grabbing from the likes table, finding the user that has given the most likes, and then we're interested in the information of that user. Once we have the liker ID, let's look at this again. Once we have the liker ID is 4, we could use this as our ID for a query select star from users, where ID equal this ID. But I want equal to this ID, and we could sort of hard code select star from user where ID is equal to 4. But what if the user was not 4, right? So what we could do is then use this query as an inner query for another one. So let's look at this. So we know that this query will return 2 columns, liker ID 4 and num of likes. Now, what I want to do is, I'm only interested actually on the liker ID, so I'm going to remove this, the count part. Note that I can remove that, and if I run this, I still get the same, liker ID 4. Because now the count is still being made, the count is being made here. This is counting how many rows end up in these groups. Right? Now, once we have this liker ID, then we could use this as an inner query for a select star from users where ID equal this. Oops. So we know that this inner query is going to give us 4. We just, whatever the result value of this query is, in this case 4, plug it in here and do select star from users where ID is equal to 1, to whatever, to 4 in this case. So I just wrap that query in parentheses. Wrap that query in parentheses and then use it as use it in my outer where clause for selecting. So let's run that. Now we have that user grabbed from the users table is Arya Stark, and she's 24 years old. Questions about the inner query, nested query, as is known? Yes?
What are some tricks to be able to parse what the inner part of a question might be asking?
It's a really good question. A good way to parse what the inner, I think what I found on my case when I was learning, just like rereading the question a bunch of times and thinking about, so from here, like if you think about this question, find the user who has given the most likes, you think, oh, I have to find the user, so that means the users table, right? But then you start to think, okay, but how do I sort of combine that with the likes table, because I have to count the likes. What I found, like my approach to work is I start sort of backwards. I start thinking of the likes table and the users, and then that also takes me to building the inner query first, and then from there, yeah, so sort of backwards, likes table, and then the rest. That's what has helped me a lot. I think, just rereading the question a bunch of times, and trying to read the question and then look at the tables that you have. Sometimes a question of this has more than one entry point that you could do it from. Here we're sort of working from the likes table. I think Sergio was showing me another one option where he worked from the users table joining with the likes table. Here's involved a join table, not really an inner query. So it's a different approach. Yeah, not sure. Maybe we should look at that one, at that other approach. Yeah. Actually, just share it out loud.
Oh, what I said.
Select.
Select name and comma Group by name.
Mm-hmm.
And order by that select count, the same that you use.
This one?
Yeah. Then you got descendant that is called DEST and limit 1.
Cool. So let's do. So there's a lot of stuff going on in this query. Let's break it down. So I guess first let's see it working. We should get the same result, which is area Stark. Nice. So both return, well, they return area Stark. Mine is returning the age of area Stark. Sergio's is returning the count, how many likes area Stark has given. So let's look at this query. So first I'm gonna get rid of this. The select name from users. I'm also gonna get rid of, for now, let's comment this, and the limit. So let's think about this from the basics. So what are we doing here? Who could explain what we're doing here? This query, the one that is uncommented only. What is this query doing? I mean,
Joining the two tables of users and likes on the liker ID equal to the ID of the user.
okay, and what will the result of that be?
A table with all information from the users and the likes.
A result table where the information is matched on, so it means that user's ID equals liker ID. So let's look at this. Maybe let's do not only select the name but also the likes.id. So if I only select the name, we're gonna end up with some repeated names. Here, let's look at it. So we're joining the likes table with the name with the users table, and we're gonna basically see what users likes what. Not likers ID. I want the post ID. Posts. But then I need to let's do post ID. Post ID. So we're joining the users table with the likes table. Whatever the user's ID matches the liker ID. And we're selecting only the name of the user and the post they liked, the post ID they liked. So let's look at this. We end up with this table, which is sort of a different table from this one, right? This one, but it's still showing the same information, just in a different way. Here we have 7 rows. We have 7 rows in this one. This is it's good to maybe look at this other approach. So here we can see that Sergio is joining these two tables where the liker ID matches the user ID, and he ends up with a table like this where we have the nearest Targaryen. She only likes post 4. Alfred likes post 4. Arya likes post 4. Arya again likes post 5. Arya likes post 7. Bran 4 and 5. So from here we can just do the same thing that we were doing earlier. Grouping by name, counting how many rows ended up in those groups, ordering descending, and then limiting by 1. So let's do group by name. So if we do just the group by name, or actually before we do that, any questions to this point? How we join the two tables? So if we do group by, okay, so this is the error that you're gonna get quite often. It says column likes post ID must appear in the group by clause or be used in an aggregate function. So this is Again, that association between aggregate functions and order by. So what this is saying is Postgres is trying to group these rows by the name, but it doesn't know what to do with the post IDs. Should we combine them? Should we maybe like put them all in a string? Should we just ignore them? What should we do with them? So one of the aggregate functions, let's look at the aggregate functions that we were looking at earlier. So there are some, as the name implies, they're used for aggregating, right? Just sort of wrangling stuff into something. Here there's count, there's average. For instance, if you want to find the average income from, I don't know, I guess pursued grads in the pursuits table, you could use average for net. From here, I wanted to show you this. It's not really needed, but so that we see the grouping by happening. There's this one, string aggregate. So what this is going to do is input values are concatenated into a string separated by a delimiter. So what this could do is group by name, and then with the post IDs, what we do is we put them on a string join. Let's look at this string aggregate. So what I'm going to do here, as the error said, the likes post ID must appear in a group by or used in the aggregate function. I'm going to use it in the aggregate function, and the aggregate function that I want to do is string underscore AGG. Let's see if I don't specify the limiter and see what happens. So what this is going to do is we're going to group them by name, and with the post IDs, it's going to put them on a string. And we should see string aggregate. Wait, is this? Let me add the delimiter, maybe comma. I think it might be due to that. No function match the given name and argument types. Let me look at this. Let's do this one that I'm more familiar with. Array aggregate. So what this is going to do is with the post ID, is going to put them in an array. And this array is a Postgres array, different from the one in JavaScript. We're actually not going to be using this that much, but I just wanted to show you how the post ID are going to be sort of aggregated. So we have array AGG post ID. We end up with this. This is a Postgres array, just that they're used in curly brackets. And we're very rarely we're going to be storing an entire array in our database or in a column like this. So, but what I wanted to demonstrate with this is that we group by name. When we were not using the aggregate function, Postgres was complaining that it didn't know what to do with the post IDs. It will be gone if you group by name. So what we want to do is aggregate those, wrangle those, in this case in an aggregate, and we do array aggregate parentheses post ID. So what this ends up doing is we end up with this result. The nearest Targaryen likes post 4. Bran likes post 4 and 5. Alfred likes post 4. Arya likes post 4, 5, and 7. And this is, I just only did this array aggregate for us to see it, to see how they were sort of grouped together. They were aggregated. The post IDs were aggregated. So what we could do is, here we could just count 2 instead of, because array aggregate is an aggregate function. Count is an aggregate function. So if we do sort of count here, we end up with how many elements, how many rows were put in this groups. So we now end up with the Daniel Sargerian likes 1 post, Brand 2 posts, Alfred 1 post, Area 3 posts. Which ones we saw it earlier here when we were sort of aggregating. So and so on. But in this case, we're not interested in what posts they liked. We're just interested in how many they liked. So we just did change the aggregate function to count, and we end up with the count of how many they liked. Here we're sort of back to where we were before. Now what Sergio did was just order by. Oh, I think Sergio, you didn't need the select keyword here. You didn't need this one. Select, just count like here ID. Actually, oh, I see why you did that. So it's better to just give it a name. So this is what Sergio had. This select, yeah. This select is not really necessary here. What we could do is instead give this a name. So I'm gonna remove this count post ID. Do yes, but what you could do also is just give it a name to this column. So look what I'm gonna do here. Count that as num of likes. What this ends up doing is we end up with this column, num of likes. And then I could just say here, instead of repeating myself here, we could just do num of likes. Oh, well, we're still doing it here. We're selecting two things. We're selecting the name and the count of the post IDs. And I'm just changing. If we don't do as, which is totally fine, you don't need to do it. This column in the result will end up with the name just count. Here I just changed the name to be something more human readable or expressive, num of likes. And then we say from user join that with likes. So join the user table with the likes table on user ID matching the likes that liker ID. Now something that maybe I haven't mentioned explicitly. Here we use, you see how in JavaScript we use the dot notation to key into objects, right? Here is sort of similar, where we use the dot notation to access a specific column of a table. So here we're saying the users table, ID column, the likes table, liker ID column. You're not gonna have nested ever. Like more than this, you're not gonna have. In JavaScript, we can have like my car, that color, that shade, right? Tables just one. Cool. So we group by name. Then we aggregate how many rows ended up in those groups by count post ID. Lastly, we order by the number of likes in descending order so that the most liked is at the top. And the last thing that Sergio did was just limit by 1 so that we only get one result. And we see that area star is the user that has liked the most posts. If we don't want the, yeah, this is fine.
What if like two users have the same number of likes?
That's a good question. I think they will be up for us to say if the user has the same number of likes, then do we want the user that has the username sort of by alphabetical order, or just the first one we found? Yeah, that will be up to us to decide which one do we really want.
I guess the program would just pick a random one.
Yeah. But then if you want to, maybe see the user that has liked the most posts, but in alphabetical order, then that will be something else.
You will have to like specify like the order by that random. It wouldn't automatically do it.
Yeah, it wouldn't automatically. Yeah. Sure.
Is there a way to like show words in a terminal like console.log in Postgres?
Well, that's a good question. I had that question at some point when I was learning. There isn't really a console.log. You mean like console.log at each step what something is doing, or
I want to see words in the terminal. I want
just words?
I want to separate my results.
Yeah.
Tons of results are like just on top of each other. Very
Yeah. You could do \echo.
Okay.
I don't know how you pronounce this. Is echo or echo? Echo. And then anything you want to say.
Oh, okay.
Yeah. So maybe you want some lines.
Yeah. Make them organized.
Yep. Yep.
In Sergio's one, if on the select line, the first one, could you replace main column count post ID as number of likes with star and get RStart's full information? Would it still run the rest of the code fine?
Oh, I cannot replace the count, so I cannot replace this part because then number of likes is being used here.
Right. Yeah,
But I think I could do this, just star. But then I'm gonna end up with more information that I might not want. Oh no, then yeah.
You need to group by star.
Then we need to group by star.
Will it work? Maybe.
I don't think it's gonna work because then we're grouping by more than one columns. But what it will do here is just select explicitly the information that you want. So let's say you want like users.id, name, age, and then we'll need to include this in the group by. Yeah. Yeah. Other questions? Yes.
Tom, if the Sergio's answer and the one we did before, do they give different results?
They're getting the same results. The only difference is that Sergio's is showing the number of likes, and I'm showing the age and ID of RSARC.
That's because I got two different people as an answer. Probably have the same likes, but
You will need to, I can share this and see you must have some differences. Let me share this.
let me share.
Do we have, let's look here. No. So I just copied those two queries. You must have something different, or maybe you have two users that have the same number of likes, have liked the same number of posts. Then we'll need to say what do we want, which of the two do we want. Maybe we want the user who's in alphabetical order, the name of the user, or so on. Yeah. Cool. So questions about getting the user that has given the most likes. Cool. So let's look at the. Oh, this was an approach that I had before. select count likes ID. Let's look at this one. This is an approach that I had earlier. Let's see if let's see how different it is from what we had before. Select count likes ID as likes given, users that name from likes, join users. Yeah, this is technically the same as what Sergio had. We can look at that. Okay, I'm gonna also share this code after. Yeah, exactly the same, just different order. Likes given, and here I just named it likes given instead of num of likes. But these two are technically the same query, just a different order. We're having join, we're grouping by the same, order by likes given, in this case nums of likes, technically the same. I'm gonna share this in a bit. Second approach, yes, this second approach was Douglas approach, which is finding the most liked posts first. Yeah, this is basically the approach that we walked through with Douglas idea. Cool. Now find the most liked post. How did people go about this one? Find the most liked post. So it's sort of similar, if you think about it, it's sort of similar to the previous one, but the opposite. In the previous one, we were looking at who is the user that has given the most posts. Now we're looking at the post that has the most likes. So it's the same framework, right? So let's look at this option 1 that I have here. Let's do this. Let's look at only this part. So here we have select post body as time likes. Well, that's the count. I guess let's see. Let's do this sort of as a pre-starting. So here, what I'm going to do is I'm going to join the users table with the posts, not the users table, the likes table. I'm going to join the post table with the likes table. And where am I going to join? I'm going to join where the post ID matches the likes post ID. So let's look at what this is going to give us. Column likes does not exist. Oh, I made a spelling mistake. Okay, oh, this is kind of hard. It's here. So here, oh, and I'm repeating some information. Let's get rid of this. So here, I'm selecting, I'm joining the post table with the likes table, and this is what I'm getting. The body of the post and the ID of the post, but I also want like do likes.id and likes.liker ID. So that we get a little bit more. Cool. So we join the post table with the likes table because we're interested in finding what is the post that has the most likes. Here I'm saying, well, these two IDs are confusing. So let's do this one as post ID. So we have, these are the post content or the body, and these are the IDs. There's no confusion in here. And these ID are the likes ID. The likes ID are here, and the liker ID. So here is sort of user 2 like my families are all wolves, that post. User 3 like that post 2, user 4 like that post 2. And I think that's pretty much it. All the others, no, this one, user 5 like I can see once again, and user 4 likes I can see once again too. So from here, us humans, can we tell what is the most liked post? Which one is it? What is the most liked post? My family are all wolves. Thank you. Now here we have to do a similar approach where we're gonna group by, then count how many rows end up in those groups, find the largest group, and return that. So having this, other questions before we move on. Owen?
So that's just how you get the different headings for the writings, show information.
That's correct, yes. It's handy for more human readable titles. So. Do you add another?
I was trying to, so, who's that line? Oh, I see. So it's, I'm trying to figure out what it's selecting.
So you're selecting the post body, the post ID. Maybe let's put this one on the left. Let's first select the post body. No, the post ID first, then the post. Select the post ID first, then the post body, then the likes ID, followed by the liker ID.
Oh, as only follows the immediate one, and then, okay.
That's correct. As only follows the immediate one. So this as is for this column. So here we have, these are the post IDs. These are the post body. This is the ID of the like, and this is the liker ID. So from this join, we find that post with ID 4 appears 3 times. That means that post has been liked 3 times. That is the post that is the most liked. So we joined the post with the likes, and we ended up with this. This is just by joining, we end up with this resulting table. Now what we can do here is then let's group by post ID, right? And here the same problem is going to happen, which is there are other columns we're selecting. What do you want to do with those once we group them? How do you want to aggregate them, right? If I try to run this, it's going to say that likes ID must be an aggregate function or appear in the group by. But I actually only want to group by the post IDs, by something that uniquely identifies the post. I'm going to get rid of all the other information that I don't need, like the post body I don't need, the likes ID and the liker ID I don't need. That was just sort of for us to visualize it first. What I do need is actually just the post ID, right? Let's look at what this gives us before we order by. This is just going to give us one column. This one column is the same one that we had when we had 3 columns up here somewhere. I can't find it. But this is just one column from the ones we had before. Then I want to group by. I want to group by the post ID, and I guess we could count how many post ID end up in those. Remember that if we don't count, we end up with distinct values. we end up discarding the number of rows that will end up in those groups. Once we count, so I'm selecting two things, the post ID and the count. We end up at 5. Wait, do we? Is this correct? No. Did we have like 4? My family walls were only 3 likes, I think. 4 likes? Oh, okay. So maybe I didn't see that last one. Let's just verify it here so that I'm just gonna copy this query, paste it here. Select post ID. I was selecting post body likes.id liker ID. Knew that sometimes I always prefer to specify the table that I'm grabbing a specific column from. You could skip that as long as there are no columns with the same name on both tables. So if I try to select like only ID, Postgres is gonna get confused because likes have ID and posts have ID too. So that's why I qualify this name by saying post.id. Specifically, I want the post ID. Likes liker ID. Cool. So let's see the table right before us. What line is this? P-SQL 260. Did I save? Oh, I forgot the semicolon. Posts.body. So that we see the table before. So this is the table that we had before. Oh yeah, so this is the table that we had before. We realized that we're not interested in the body, we're not interested in the ID, we're just interested in how many times the post has been liked. So from here, we moved on to just this. Actually, before I counted, before I group by count, this sort of here. So we had this just by joining the two tables. Joining the post tables with the likes table, we end up with this. We realized we were not interested in body ID or the liker ID. We're just interested in the post ID. So this column here that we're seeing is technically this exact same, just disregarding the other information. Here, what we're going to do is we're going to group by the post ID, and what we want to do is count how many rows end up in each group. So here, the group for row with a poster ID 4 is going to end up with 4 rows. The group for row with ID 5 is going to end up with 1 here and 2 here, 7, 1, and that's it. So once we move from there, let's sort of do it on another one, I guess, too. Comment this. Let me finish this one here. So from here, the next thing that that we're going to do is we just want to group by. In this case, we can group by the post ID as well. And I want to count how many rows end up in these groups. Post. So from here, we end up with something like this. So note how we moved from here. From here, we moved to only this. Then we group by the ID. As I said, the group for post ID 4 ends up with 4. That's the number of likes that post has received. The group for post ID 5 ends up with 2. That is the number of likes, the number of rows that that we had likes for poster 5, and 7 with 1. Does this make sense so far? So once we have the count of likes, basically here what this table is showing is the count of likes of every post. Count of likes of every post. 5 has 2 likes. So actually, let's do as times liked. So post 5 has been liked 2 times. Post 4 has been liked 4 times. Post 7 has been liked 1 time. So from here, we just go back to what we saw earlier, where we went to order them by the number of likes, limit by 1, and get that one. Questions before we do the order and limit? This is going to require practice. Cameron?
I wanted to try a different way to see if it can do the same response, like shorten it. In like compare. So basically just to do select post ID, count post ID from likes by group by post ID, and order by count post ID.
So you don't need to join, right?
I think so. I get the
Yeah.
same response, so I wonder if it worked for you too.
That's correct. So yes, we don't need the join. The join sort of was for us to see the post match to the likes for demonstrating purposes. But yes, we could just do this with the likes table without needing to join, actually. But before we do that, let's do, so group by, we are doing that. Yes, do this.
Why is group by in parentheses?
Oh, that is my, not mistake. I got used to putting in parentheses.
Oh, so it works out.
Yeah, it works either way.
Okay.
It is not supposed to be in parentheses because group by is not a function. Count is a function, and so on. Yeah. Good question. So group by that, and then let's count by the times that it was liked in descending order. That ends up with this table, descending order, and then with limit by 1. Limit by 1, we end up with the post 4. Oh, so Cameron, I guess like we don't really need the join, but if we wanted to show the content of that post, we will either need a join or a nested query. So in here, if I want, let's say I want the body of the post that we liked, to just say post.body. So that we return the post ID, the body, the content of that post, and how many times it has been liked. Yes.
Is there any way to put an if statement in this where it is sort of like limit, like if result equals 2, limit 2, if result equals 1, limit 1?
We'll do that from JavaScript, which is what we're going to learn today, how to talk to the database with JavaScript. I have tried to put if statements in SQL directly. I haven't been able to figure it out. I have tried to do like quite some stuff, but that is sort of that more complicated stuff. We just move to JavaScript and do it from JavaScript. So cool. We have that the post my family are walls has been liked 4 times. Now think about a real world example where this query is used. The apps you use every day, you probably check that app today. Joy?
Facebook or Instagram up likes or up?
Okay, yep. Yeah. The trending, I think. The trending areas. Their query is probably more complicated than this, but this is definitely a start. Trending in any, like, in Twitter, in Facebook, in Instagram. Right? Now, I don't know if you can sort your posts by the most liked. Like when you are on Facebook profile, can you sort your own posts to see which one is the most popular? Well, this could be a way. Other questions, comments? Cool. So let's look at the last one before we take a break. This was another approach to this same one, where I did like a nested query. Similar approach to the earlier one. Let me see. Oh, maybe this seems to be select from user ID. No, this is from the earlier one. You can just ignore this. I have to organize this before I send it. Here, this one. Find out the information of the user who posted the most liked post. Find all the information of the user who posted the most liked post. This query is to find influencers, or so-called in the social networks. So here we have the most liked post. So from there we can just grab, who posted that, and literally plug this same query, plug it into select users from, select star from users where user ID is equal to poster ID. Once we have the most liked post, we can just literally copy that as the inner query for another one. So let's see, I think I had that here. Yeah, this is actually that query. Just look at this. So here I have a nested query. This one is selecting what we were just doing, selecting the most popular, the most liked post. Just doing it in a slightly different way. Post ID, joining the post with the likes on post ID, then grouping by post ID. Then here, instead of counting like the post ID, I'm counting the post body. It's the same thing. Descending, so this is exactly the same. Grabbing the most popular post. But note here that this is inside of an outer query, which is select star from users. Join posts on user ID equal post.poster ID, where post ID matches the post ID, the most popular post. So here, I actually didn't need this join. Because from this query, we could just select the poster ID, I think. Yeah. So this inner query finds the most liked post. Then the outer query, what it's doing is going with the result of this one, which the result of this one is the most liked post ID. With the result of this one, I'm going to join the users table and the post table, and then find where the match between the ID that I found to be the most liked matches the post ID that is joined to the users table. Now what that ends up doing is, if we run this, I thought this post belonged to Jon Snow, but it seems that it's maybe in the inserts maybe making a mistake. Here's Daenerys Targaryen. Poster ID 2, yeah. It's a mistake that I made on my insert. This post is supposed to belong to Jon Snow. We can ignore that for now. But here, this is the result of that query. So first, I'm finding the post, the most popular post. We saw that it was "My family are all wolves" here. And then once I have that post, I join the users table with the post table, and I'm finding in that join table, I'm finding where does the most popular post ID matches one of those rows. And it matches on Daenerys Targaryen, and gives me all the information from her. Questions, comments? So this is another example of a query where I like to think backwards. First, find the user who posted the most liked post. First, I'm going to find the most liked post. And then after I have the most liked post, I have the ID of that post. Then I can go to the post table and find who was the poster ID. Yeah. So these were those queries. Other questions, comments? So similar to what we do in JavaScript, it's sort of breaking the problem into smaller pieces and then putting them together. So you could also think about this sort of like a function. This function does one thing. This select is doing one thing, and then it's going to pass that result to something else, which is the outer SQL query. Let's take a 10-minute break and get excited to talk to Postgres with JavaScript.